चलो, आई होप वी आर लाइव। सब लोग कमेंट में लिख लीजिए। वालेकुम अस्सलाम। Okay. Today's topic is NLM, that's Newton's laws of motion. Newton's laws of motion. Shall we start? Oh yes. Shall we start? Okay. सब लोग आ गए हो तो आवाज आ रही है? Okay, we will start. We'll start. Wait 1 minute. अजान हो रही है. Wait 1 minute. Okay, we will start. Today's topic is about, that is Newton's laws of motion. Today's topic is about Newton's laws of motion. So we know about the Newton's laws of motion. Today's marathon session regarding Newton's laws of motion, we'll discuss every topic and what are the different problems regarding Newton's laws of motion. Like we will discuss here block problems, like we will discuss here inclined plane problems, like we will discuss here what are the problems related to pulley. You know that pulley problem is one of the most important problem regarding your examination. Let it be it's a NEET examination or whatever, let it be it's a JEE examination. It's a favorite question for an examiner that a question comes from a pulley problem. Also we will discuss here constraint problems. What are constraint problems? I hope it's visible to you. I hope it's visible to you. So let's start. This is what we are discussing, that's NLM. NLM means here Newton's laws of motion, and we will discuss this NLM in one shot. NLM in one shot. Tell me okay. Tell me, is it visible to you? Tell me, is this visible to you? Tell me, is this visible to you? Please write in comment section, is this portion visible to you? Okay, everyone comment yes. Okay. Okay, so let's start. First of all, we will discuss here what are the different forces acting on a body. We know that if there is a block, suppose this is a block, it has some mass, suppose it has mass m. What is the force acting on this body? What is the force acting on this body? You will tell the force acting on this body is W equal to mg. That's the weight. So what is a weight? Weight is nothing but it is that type of force which is a pulling force. It's not a pushing force, because you know that earth attracts every body towards itself with a force that is called the force of gravity, and the magnitude of that is called W equal to mg. It's the weight of the body. And also we can calculate that F equal to gm and m2 upon r square. That is same, because gm upon r square it's small g, and we can calculate what is the weight of the body. This is the first force that we have discussed, that weight of a body it's nothing but it is a pushing or pulling force. Weight of a body, it is a pulling force. It is a pulling force. I hope you know what is a pulling force. Second thing we will discuss here, that's a tension. That's the tension. Suppose we have a string and a block is connected to that string. Suppose this is a string, and we will discuss here massless and inextensible strings. Sorry, because it's not visible to you. We'll write here one thing I can do. Yes, this is a string and a mass is connected to that string. Suppose it has mass m, but the mass of string is massless. We'll discuss massless and inextensible. What is, sir, massless and inextensible? The string which do not have any mass, and the string which is inextensible. Inextensible means that there is no constrictions. What do you mean by that, constrictions? If you want to you discussed what is elasticity. Yes, rubber is an elastic material. It means you can increase its length. You cannot increase the length of that string also. We assume that the length of the string doesn't increase also, and we also discussed that this string it is massless. We assume, but there is some mass. But in every question it is also given that the string is massless and inextensible. Suppose there is a mass m. What will happen? Due to the weight of the body, there will be weight of the body W equal to mg on this body. The force which will act on a body, that will be W equal to mg. Okay. Next thing, what will happen? To remain this string at its point. What will happen? A restoring force will come into play. A restoring force, that's called a cohesive force. Cohesive force is that force which is between the particles, which is between the same particles of the material. Adhesive is the force between the different particles, like adhesive tape, it is between the different bodies. Cohesive force, it is between the molecules or atoms of same body. In the same way, in string there are number of particles. What will happen? A restoring force, that's a cohesive force, will come into play such that which will bring these particles back to their original position, because we know that the length cannot be increased here because it is an inextensible string also. What is that force which comes into play in any string such that it will make all the particles at their own position? That force is called a tension. Tension is a force which comes into play in strings when an external force is applied on a string. What is the applied force? Due to the block, there is an external force W equal to mg. And also what is the force which is in the string? That is the tension. And you also know that if the body or this block, if the system remains stationary, this tension will be equal to the weight of the body. And also you know that tension, is it a pulling force or pushing force? It's always a pulling force. Remember that it's always a pulling force. Tension is always a pulling force. What do you mean by pulling force? Which always pulls the body. And whenever you have to assign what is the direction of the tension, what you have to assign the direction of the tension, always tension is away from the body. Always tension is away from the body. wait a second. Okay, nice. Now if I tell you what is the direction of the tension here, what is the direction of the, let it is mass m1, it has mass m2, they are placed on some smooth surface or frictionless surface, or you can say that there is no friction. Suppose there is an applied force F, where system will go? System will go in this direction, system will go in this direction, but there is a force which comes into play, which is always away from the body, that's called the tension. Suppose this is a string, there will be a tension, that will be this tension T, and also this will be a tension, because tension is always away from the body. If you are concerned, what is the free body diagram of this body? What is the free body diagram? Free body diagram is that diagram in which you take one of the parameter of the you take one of the body from the system, because system consists of number of bodies. You take number of the bodies in a system, take one by one what are the different forces acting on that body, that's called the free body diagram. Suppose what is the free body diagram of this M2? You will say, sir, a force F comes into play, in this direction, and also a tension which is restricting that, then what will happen? There will be some exertion in this direction, because system is going in this direction. If force F is greater than this tension, then system will go in this direction. So what are the different forces? That is F, and another one, that is T. What is net force? Net force on the body, it is where is the body going? Body is going in this direction, it will be F minus T. Hope you understand. Similarly, if I will tell you what is the free body diagram of this mass M1, what are the different forces acting on this body? Different forces are there also. Yes, I know. You are telling, sir, one force is there, that's called the weight of the body. That will cancel out with normal reaction. I will tell you what is a normal reaction also. What is the force acting on this body? That is tension. Due to tension, this body is moving in this direction with some acceleration. What is the net force on this body? You will tell net force on this body M1, it's nothing but it is equal to tension. I hope it is clear to you. I hope it's clear to you. Okay. Now tell me, what is tension? Tension is nothing. Yes. Tension is nothing, but tension is which type of force? It is a pulling force. What is the weight of the body? Weight of the body, it is a pushing force. Tension comes into play whenever there are strings, and weight is always acting on a body. It's always acting at the center of the gravity. You know also that. Now the third one, if you see on your screen, third one, it is normal reaction. What do you mean by normal reaction? Can you tell me? What is a normal reaction? Can you tell me what is a normal reaction? Okay. Yes, I know most of you, and I hope all of you are knowing that what is a normal reaction. Suppose this is a body. This is a body on an inclined plane. Inclined plane means when you raise the outer edge with respect to inner edge at some angle. Suppose this is an angle of inclination, that is theta. Suppose the mass of this body is small m. The mass of this body is small m. M is equal to mass. What are the different forces acting on a body? Can you tell me? Suppose this is a smooth surface. You will tell the force W equal to mg. That's the weight of the body that is acting on this body. Weight acting on the body, that is W equal to mg. Now what is another force? Can you tell me? Yes, one force which is always, is that a pushing force or pulling force? That is always the pushing force. That force which is normal to a body whenever two bodies are in contact. The force which is normal to the body. Normal to body means it is at a perpendicular. It is also perpendicular. Normal means perpendicular at a point. So where? At a point of contact. This is a point of contact. The force which comes into play whenever two bodies are in contact, that force is called a normal force. It is always normal to the body, and for symmetric bodies it crosses through or it passes through the center of the body, because For symmetric body, like square is there, like you have cube is there, these are symmetric bodies. What is the normal reaction? It will pass through the center of gravity is coincides with center of the body also, you know that. Okay, now what will be the normal reaction? Who give the normal reaction to this body? This will give normal reaction to this body. Like when you are walking, you are pushing the surface. When you are walking, you are pushing the surface. Same when you push the surface, does the ground goes inside? No sir, because ground gives same equal amount of force according to Newton's law of motion, third law of motion. For every action there is equal and opposite reaction. Ground gives same amount of force in opposite direction. It means when two bodies are in contact, there is a force which is equal in magnitude but opposite in direction. That force is called normal force. On this body, normal force, it will be normal to body. Let me suppose normal, it is R or N. We write normal reaction by R or N. Why R? Because force is, the unit of force is Newton, that is denoted by capital N. That's why in some cases we write by R, or you can write by capital N. No issue. Okay, nice, low. Okay. Now what is normal reaction? Normal reaction is nothing but that is the normal to the body. It's always normal to the body at a point of contact. Now can you tell me what are the different forces acting on this body? Sir, one force is weight of the body, that's W equal to mg. Another force is the normal reaction. Now I will tell you, can you split the weight of the body in two different directions? Yes. Can you resolve this? Yes sir, we can resolve. This is the weight of the body, W equal to mg, which is always towards the surface of earth, and one force is normal reaction. If this angle is theta, can you tell me what is this angle? This angle is also theta. Okay, if my English can cause cancer to you, it's okay for you. Okay. Who can understand my English? They are waiting for me also. They are seeing the lecture. If my English is not good, what is the fun in that? The fun is that, are you studying here? Or tell me. Okay, if this angle is theta, then what is this angle? This angle is also theta. Now can you resolve this force? Yes, we can resolve any vector in two different directions. One is the horizontal component and another one is the vertical component. Sir, what is horizontal component? Horizontal component is that component where this angle theta comes into play. Remember that where there is a theta, there is a horizontal component. What is this thing? This is mg. What will be this? Mg cos of theta. What will be this component? It will be mg sine of theta. Mg sine of theta. Tell me where this block will go. Sir, this block will go, if this is smooth surface, this block will go in this direction. Net force comes into play in this direction. How much is that net force? That net force, it's equal to mg sine theta. F net, it's equal to mg sine of theta. F net is equal to mg sine of theta. Why sir? Because in vertical direction there is no acceleration. Body is not going in vertical direction. Body is only going in horizontal direction. Either it will go up in the inclined plane, either it will go down to the inclined plane. But the thing is, there is no friction. The only force which can restrict this body, that was the friction, but there is no friction. This is a frictionless surface, or this is smooth surface. The net force that's also in horizontal direction, that is F net mg sine theta. Sir, if it is not going in any of these directions, vertically upwards or downwards, what will be then normal reaction? It will be equal to mg cos of theta. It means this is an this condition, it's an horizontal vertical equilibrium condition, because no acceleration in vertical direction, it means net force acting on a body, those are equal and opposite. N will be equal to mg cos theta. I hope it's understand. Don't report. Why you are reporting this? They are making fun of the teachers. Anyone is allowed who can come. The one who is studying, study please. Don't give interest to these kinds of, they are telling. I hope it's understandable to you that net force on a body, it will be equal to mg sine of theta. If there will be friction, what will happen? Tell me, if there is friction, what will happen? Sir, a friction will oppose this body in this direction. If the body is going in this direction with some acceleration A, if there is some friction, and you know that there is a frictional coefficient, that's called a coefficient of friction, mu. That is called coefficient of friction. Where will this friction force will act? Frictional force is always opposing force. And that frictional force will be acting opposite to that of applied force. It will be in this direction. We denote the frictional force by small f. And you also know that this frictional force, it depends upon normal reaction. More is the contact with the surface, more is the friction. This frictional force will be equal, constant of proportionality will come, mu into normal reaction. Sir, what is mu? Where mu is called the coefficient of friction. Whenever, if there is only tendency of movement between the two bodies, it means a body wants to move on this surface, but it is not moving. It means there is only tendency of motion, the friction that comes into play, where there is a relative motion between the two bodies, such that there is only tendency of relative motion. There is no actual relative motion. Relative motion means that when one body moves with respect to other body, but here if there is only tendency, this body wants to move, this body wants to slide with respect to this wedge, or inclined plane, but it is not actually moving, then the force of friction that comes into play, that force of friction is called static friction. That force of friction is called static friction. And now, how much is static friction? You will tell static friction Fs, it will be equal to mu s into normal reaction. Sir, what is mu s? The coefficient of friction that comes into play here, that's called the coefficient of static friction. Sir, what is now static friction? Friction force is that force which comes into play whenever there is a relative motion between the two bodies, when one body wants to slide or move with respect to the other body. But if there is only tendency of movement, but actual movement is not there, like this wants to move with respect to this wedge, but there is no actual tendency between the two bodies. If there is not the actual tendency between the two bodies, then what will happen? A frictional force that comes into play, that's called static friction, and there will be a coefficient that will be called coefficient of static friction. I hope it's clear to you. Okay, next is what will happen if we increase this net force? This friction force wants to move this body in this direction, but F net, that F net here, it's equal to mg sine of theta, that wants to move this body in this direction. Now what will happen, this frictional force, if we increase this net force, frictional force will increase, because frictional force is a self-adjusting force. Suppose if this force it is 10 Newton, then how much will be the frictional force? Frictional force will give only 10 Newton. It will not give you 11 Newton. It will give only that amount, such that it will cancel out this net force. If this is 20 Newton, it will increase up to 20 Newton. If this is 30 Newton, it will increase up to 30 Newton, so that this body will not move. But there will be some limiting value of this friction. That limiting value, or the maximum value of static friction, that's called a limiting friction, FL. FL is nothing but it is the maximum of static friction you will increase. Suppose the limiting friction it is 40 newtons. It means if you apply 40 newtons of force in this direction, then what will happen? This body will not move. Friction will give you 40 Newton. But what if you give 41 Newton? Now frictional force will not work. Why it will not work? Because frictional force is less. Sir, you tell earlier that it is self-adjusting force, but it is self-adjusting force up to some extent. That extent is called the limiting friction. There will be the maximum value of what? There is a maximum value of this static friction. That maximum value is called limiting friction. And if you increase further net force, what will happen? Body will go in this direction. Body will go in this direction. Then is there any friction? Yes. If there is actual movement, there is a movement between the two bodies, actual movement, but also there is some friction, but that is less. The friction that comes into play in opposite direction to that of applied force whenever there is actual movement between the two bodies. Such a type of friction is called, yes, kinetic friction. Kinetic friction, denoted by Fk. What is Fk? Fk is nothing, it is kinetic friction. Now what will be the value of kinetic friction? The value of kinetic friction, it will be equal to mu k into normal reaction. Why? Because kinetic friction, the coefficient will be coefficient of kinetic friction, and you also know that this kinetic friction is less than static friction. Or sir, what is limiting friction? It's the maximum value of static friction, because in static friction there is no actual movement. It means static friction is greater. In kinetic friction there is actual movement. It means static will be greater than that of kinetic friction. If we say this will be equal to mu k into normal reaction less than mu k into mu s into normal reaction, this will cancel. It means mu k is less than mu s. Coefficient of static friction will be greater than coefficient of kinetic friction, or coefficient of kinetic friction will be greater than coefficient of static friction. I hope it's clear to you. Okay. These are the basics that are related to Newton's laws of motion. And also you know that what are the three laws of motion? Can you tell me what are the three laws of motion? I will do one thing. Okay, I can do one thing. Yes. You know that what is tension? Also I can tell you what are different problems related to these pulley. I can tell you. Yes, first law, you know first law of motion. Yes, sir, we know what is first law of motion. You know that first law of motion, every body continues to remain in a state of rest or uniform motion until and unless an external force or unbalanced force acts on it. And second law is that is the rate of change of momentum is directly proportional to the external force applied on a body. You know that F is equal to dp by dt or F is equal to ma. You know this. And third law, for every action there is a equal and opposite reaction. But why? Whenever two bodies are in contact. Yes. And you know also this thing. Yes, I will tell you this thing. What is this thing? Yes, you know this. Yes. What is this thing? There is actual motion. Yes, kinetic friction is there. What is this? There is no actual motion. Why? Because if you see a person which is giving some force, but the person is very tired. Why tired? Because he is giving too much amount of force, but the frictional force is always opposing this. But there is, this thing is limiting, this value is limiting, and it gives the force greater than that of limiting friction. What will happen? A body will move, this body will move in what direction? In what direction exactly? In what direction? In this direction. Yes, Akash, yes, this is law of inertia. First law of motion is law of inertia. Exactly. I hope you understand these kinds of things. Okay, nice. We'll tell you one thing. What is this thing? Suppose this is a body. And you are giving some applied force. In this direction. If you give applied force in this direction, if this is a rough surface, frictional force will come into play in this direction. I hope you understand. What is also force? Another force, that is normal reaction. That's in this direction, normal to body, and there is a weight of the body in this direction, W equal to mg. Now tell me, this is a frictional force. This is the resultant of the two forces. This frictional force is nothing but it's mu times normal reaction. If it is static friction, there will be mu s. If it is kinetic friction, there will be mu k. Now there is some angle between the resultant. This is resultant, F net, we will tell. Resultant of what? Resultant of frictional force and normal reaction. The angle made by resultant of frictional force and normal reaction with normal reaction or with vertical, that angle is called angle of friction. That is denoted by alpha. Angle of friction. So what is angle of friction? Angle of friction is the angle made by normal reaction with the resultant of frictional force and normal reaction. In the earlier case, what we see in earlier case, we see that if this is an inclined plane, this is a body, the force mg comes into play in this direction and the normal reaction comes in this direction. If this angle is theta, then this angle also it is theta. We can resolve this force in two directions. One is mg cos theta, where there is theta, there is cos component, and another, that is mg sin theta. These two components are at right angles with each other, mg sin theta and mg cos theta. The result of these two is mg. And if there is a friction, body will move. What is driving force? Can you tell me what is F driving force? Which force is moving this body? It is mg sin theta. But if there is friction, an opposing force will come into play in this direction. That's called a frictional force. That's equal to mu times normal reaction. Whether it's static, if this is static friction, mg sin theta will not counterbalance this frictional force, because if this is static, body will not move, mg sin theta will be less than that of frictional force. If it is kinetic, if the body is moving, then what will happen? The body will go in this direction. Can you tell me what is opposing force? F opposing. Sir, F opposing, it's nothing, mu times normal reaction. But can you tell me, body will either move in this direction or in this direction, depending upon this driving force is more or this frictional force is this more. But body will not move in this direction. It means normal reaction will be equal to mg cos theta. It is in equilibrium in vertical direction. Normal to body. This is not the normal reaction. It's wrong. It is not normal to the body. It's normal to the body is this thing. Normal to the body is this. This is not normal to body. I hope you understand. This is not normal to body. Always, if this I can draw normal here, this is normal to body. It's not always like this. You have to see normal to body. If the body tilts, then the normal reaction also tilts. Okay. Now what is opposing force? Mu times normal reaction. It's mu time. How much is normal reaction? Mg cos theta. Now tell me, suppose initially frictional force is more. Suppose frictional force, the body will be at rest. It means mg sine theta will be equal to mu times mg cos theta. If the body is not moving, if the body is not moving, what will happen? This driving force and this this frictional force will cancel out. M and M will cancel out. It means g sine theta will be equal to g cos of theta. I can tell you also that, skip this thing, I can tell you this driving force. I can also tell you if initially if this is equal, then what will happen? It will not move. If theta increases, I have to explain another thing, that's angle of repose. If theta increases, what will happen? This m sine theta will increase. Why? Theta increases, the value of sine theta increases. If theta increases, what will happen? This force will increase, this force will decrease. Then what will at a stage this mg sine theta and mg cos theta, at a stage this mg sine theta and this mu times normal, that is mu times mg cos theta, they will counterbalance each other. That angle, the angle of inclination at which this driving force, this opposing force are equal, that angle is called the angle of repose. At suppose theta equal to some lambda or phi, theta equal to phi, what will happen? Driving force and this force will cancel out. It means mg sine of phi will be equal to mg sine of phi will be equal to mu times mg cos of phi. Why phi? Because at a particular angle these two forces will counterbalance each other. In the first case this was greater, suppose it is greater. If it is greater, a body will try to move in this direction, but when you increase theta, this will also increase, it will decrease, it will increase. At a stage these two forces will be equal. M and M will cancel out, G and G will cancel out. What is sine phi by cos phi? It is tan phi. Tan phi will be equal to mu, phi will be equal to tan inverse mu. This phi, if you know the coefficient of friction, then what will happen? You can calculate angle of repose. Angle of repose is nothing but it is the angle at which driving force and this opposing force, those are equal. That angle is denoted by phi. You can write this as alpha, lambda, whatever, but you can calculate if you know the coefficient of friction. I hope you understand this. Now we will move towards the questions. This is the first question for you. Can you tell me the answer for this question? This is the first question for you. Can you tell me the answer? First question for you. Tell me the answer fast. Tell me the answer. First question for you. A machine gun fires a bullet of mass 20 grams. A machine gun fires a bullet of mass 20 grams with a velocity of 1200 meter per second. The man holding it can exert a maximum force of 72 Newton on the gun. How many bullets can he fire per second at the most? How many bullets can he fire? Can you tell me the answer? Can you tell me the answer? Safula 3. Arif. Thank you, Arif. Can you tell me the answer? What's the answer? Safula said it's 3. We'll see. Anyone else? I fast. What will be the answer? only one answer, no one is giving answer. RE4. Anyone else? Rizwan 3. Rizwan 3. Hafid 3. Hafid 3. Khan Farzana 3. Most of you are giving answer 3. It means the answer should be 3. We'll see what will be the answer. We'll see. What is giving? A machine gun fires a bullet of mass 20 grams. The mass of bullet, let it be, it is small m, it's equal to 20 grams. We can convert it into SI system. 1 gram will be equal to 10 to power minus 3 kg. 1 gram will be equal to 10 to power minus 3 kg. With a velocity of 1200. What is the velocity? 1200 meter per second. The man holding it can exert a maximum force of 72 Newton on the gun. Can you tell me it's on recoil velocity of gun? You discussed it. There we use law of conservation of momentum. You know what's law of conservation of momentum? That initial moment is always equal to the final. If net force on an isolated system, it's equal to 0. Now here the velocity of the body is given as what is net force? That is net force. That's a maximum. How much is the maximum force that a person can give? That maximum force is 72 Newton. How many bullets can he fire per second at the most? How many bullets he can fire? Suppose the number of bullets, it's small n. Small n is number of bullets. That's number of bullets. Then what is F net force? F net, it's nothing but it's equal to change in momentum per unit time. You know that net force on a body according to second law of momentum, that is change in momentum with respect to time. F net is equal to change in momentum with respect to time. But you know that how much change in momentum is there? You know that F is also equal to ma. I can write here F is also equal to m into a. But how many bullets, let it be force, it is equal to force. On how many bullets force is acting? It's n bullets. There are n number of bullets, or small n. I write here small n. There are small n number of bullets. What is momentum? Momentum is nothing. It's mass into velocity. You write here m into del v upon delta t. What is F net? It is 72. How many bullets? N upon delta t. I can write here. What is the mass? How much is the mass? It is 20 into 10 to power minus 3. How much is the speed? How much is change in velocity? Final velocity minus initial velocity. You know final velocity, it's change, we can write n into m into v final minus v initial upon delta t. Final velocity minus initial velocity of the bullet is 0. Final velocity, how much is the velocity? It's moving with 1200 meter per second. What will be changed? 1200 minus 0, that will be 1200. I can write 1200 as 1.2 into 10 to power 3. 1.2 into 10 to power 3. Is it this? Yes. 10 to power 3 will cancel out with 10 to power minus 3. Okay. Now what will we are left? N upon delta t. That's number of bullets per unit time that are fired. That's equal to 72 divided by 20 into this. It will be 12 into 2. That will be 24. That will be equal to 24. And on solving, what will be the answer? Twelve 3R. Answer should be 3. Yes. Answer 3 is correct answer. 3 is correct answer. 3 is right answer. Yes, 3 is right answer. Now next question we will see. Okay, can you tell me the answer for this? Tell me the answer for this. The next question, the apparent weight of a man inside a lift. The apparent weight of a man inside a lift moving with certain acceleration is 600 Newton. When the lift is coming down with same acceleration, apparent weight is found to be 200 Newton. The mass of the man is given by. Can you tell me the answer? Fast. Tell me the answer fast. What will be the answer? What will be the answer? First lift is going up, second lift is going down. Tell me fast answer. Tell me fast answer. Come on fast. Tell me the answer. No one is giving the answer. No one is giving the answer. Can you tell me the answer fast? Comment fast. Okay, I will do this question. Okay, what's asked? Here we have to calculate the mass of the body. There is some lift, there is a man inside the lift, and first the lift is going upside. First the lift is going upwards or upside, and second the lift is going downwards. Lift is going downwards. How much we have to calculate the mass of the man is? Suppose in first case, two cases are there. Second question, case first and case second. In first case, what is? Lift is going up. If this is lift, a man is inside the lift, suppose, what will be the force? W equal to mg. Downwards, if m is the mass of the body, what will be the weight of the body? And normal reaction will be n will be equal to mg. N will be equal to mg. And where is lift going? It is going upwards with some acceleration. Suppose that acceleration it's equal to a. In second case, the lift is going downwards with some acceleration, same acceleration it's giving with the same acceleration, that is a acceleration. And what will be the force? Mg in this direction, and there will be different normal reaction. Why? Because in the first case it was moving up, and in the second case it's moving down. There will be different weight. You feel different weight when you go upwards, you feel different weight when you go downwards. When you go downwards, the weight will be lesser or greater. Yes, it is lesser. What will in first case, what is net force? What is net force, sir? Net force is equal to mass into acceleration. Always net force is equal to mass into acceleration. But how much is this? A body is going in this direction. It means net force will be this force minus this force. N minus mg. It will be equal to ma. And in this case, what will be the net force? F net, that's equal to ma. It will be equal to, body is going in this direction, mg minus n dash. That's equal to ma. What will be the value of n? It will be ma plus mg. What will be the value of n dash? It is equal to mg minus ma. I can write this also as n equal to ma plus mg. I can write this as n dash equal to mg minus ma. When we add these two equations, what will happen? This will cancel out with this. N plus n dash. What is the value of n? That is, in first it is 600 Newton. That's the weight. In second case, how much it is? 200 Newton. And that is equal to mg plus mg is twice mg, twice m into what is the value of g? It is given that take g equal to 10. It will be 800 upon 20. It will be equal to m. This will cancel. 240 R. Mass of the body is 40 kg. Mass of the body is 40 kg. Yes, Hafid, 40 is right answer. Yes, Rizwan, 40 is right answer. 40 is right answer. Yes. I hope it's understandable to you. Okay. Next question. Next question. We'll see next question. Tell me the answer for this question. Tell me the answer for this question. Tell me the answer for this question. What is the question? A fireman wants to slide down a rope. A fireman wants to slide down the rope. The braking load for the rope is 1/4 of the weight of the man. What is braking load? Whenever there is a rope, there is a force that's called a tension. Remember that there is tension. And that tension is 1/4 of the weight of the man. With what minimum acceleration should the fireman slide down? Acceleration due to gravity is g. What is the minimum acceleration that the fireman goes down? Take g, the acceleration due to gravity equal to g. It means you have to give the answer in terms of g. Tell me fast, tell me fast. I will give you 1 minute for this question. Tell me fast, what is the answer for that? Very easy question, very easy question. Comment fast. Is it option A, B, C or D? Tell me fast, what is the answer? What's the answer? No one is giving the answer? Yes, I will do. Will do. What is asked? What is asked? There is a fireman and which is going, I think upwards. Yes, there is a fireman. A fireman wants to slide down a rope. Sorry, he wants to slide down. It means there is a rope and there is a fireman. Suppose there is a fireman. This is a fireman. Wants to go down the rope. This is rope. What are the different forces that are acting on a body? What are the different forces? Can you tell me? Hafid, C. Rizwan, C. Yes, C option is correct answer. C option is correct answer. Yes. Can you tell me what are the different forces? One is mg. That's downwards. What is another force? That's restricting. That is tension. But body is going downwards. Where will be the net force? Net force will be downward. It means this force is greater, this force is smaller. It means F net, it will be equal, that's equal to mass into acceleration always. Net force is equal to mass into acceleration. But here, what is F net? It is mg minus t. Why not t minus mg? Because body is going downwards. If body is going downwards, what's net force? Mg minus t equal to ma. And it's given that the braking load for the rope. What is braking load? That is called the tension. That the maximum tension, that is 1/4 of the weight of the man. Weight of the man is mg. What will be the tension? Tension is given. It's 1/4 of weight. That's mg. It will be mg upon 4 is equal to ma. 4 mg minus mg is 3 mg upon 4 is equal to ma. M and m will cancel. Acceleration will be equal to 3g upon 4. The minimum acceleration with which, yes Sharik, option C. Yes Rizwan, option C. The minimum acceleration with which it will go, it's 3g upon 4, and that's option number C. Option C is correct answer. Okay. Are you ready for next question? Yes. This is next question for you. This is next question for you. Tell me the answer fast. It's a very simple question. It's a very simple question. Very simple question. We did this question earlier. We do this question in this session earlier. First question was based on that question also. Tell me answer for this question. 1 minute is for you. What is the force? Calculate the force necessary to hold the gun in its position. What is that force? That will be in opposite direction. What is that? Rizwan Hakak. It's 1200 Newton. 1200 Newton. We'll see. Option D. Sharik, option D. Option D. Option D. Yes, option D is correct answer for you. As half a 2400. Yes, option D is correct. Option D is correct. I hope everyone is doing the question. Option D is correct answer. Yes. How? You know F net. What will be the net force on a gun? That will be how many? What is the net force? You have to apply the net force on n number of bullets. N number of bullets into mass into acceleration. It's n, it's mass. What is acceleration? Change in velocity upon time. Change in velocity is nothing, v final minus v initial upon time, delta t. How many bullets are there? It's given that conversion of 4 years. A machine gun fires 20 bullets. It's 20 bullets multiply. What is the mass? It's 150 grams. You can convert that in SI system. It will be 10 to the power minus 3. What is the velocity? Initially 0. Finally it's moving with a velocity of 800. Minus 0 will be 800 upon. Yes, you have to find the necessary force to hold the gun in its position. Yes, it will be. Yes, you have to apply the force. Oh, sorry, this is number of bullets per second. This is number of bullets per second. Per second will cancel out. What will be the answer? It will be equal to 20 into 150 into, it will be 10 to the power minus 3. We can write 8 into 10 to the power minus 10 to the power 2. We can write this as 15 into 10 to the power 1. 10 to the power 1, 10 to the power 2 is 10 to the power 3, 10 to the power minus 3 will cancel out. 20, 15, 18, 18 into 2 is 160 into 15. It comes out to be 2400 newtons. Isn't this? Yes. Okay, nice. 2400 is the right answer. Okay. Yes, next question for you. Tell me the answer for this question. Tell me the answer for this question. Tell me the answer for this question. Very easy question. Similar type of question that we do is a lift problem. Type of lift problem. Because machine, weighing machine and lift, similar type of problems are asked. Similar type, not the same type but similar type. Tell me answer for this question. Tell me answer for this question. What's the answer? No one is giving the answer. Tell me fast answer. Will do myself. What is the answer? What will be the answer? It's given that there is a body of mass 80 kg stands on a weighing machine in an accelerated lift. There is an accelerated lift. The reading, if there is not mentioned, where will the lift go? The lift will go downwards, because due to acceleration, due to gravity, gravity will force this lift to go downwards. The lift will go downwards. The lift will go down. There is a lift. This is a lift, and a body is standing on this lift, and there is some weighing machine, and the lift is going downwards, some acceleration. What will be the forces? That mg. What will be the normal reaction? That is n. That is the weight of the body. It's given that what is the net force of the body? Acceleration is downward. What will be the net force? F net. It will be equal to, sir, mg minus n, and F net is equal to mass into acceleration. It's equal to mg minus n, and acceleration will be equal to mg upon m minus n upon m. M and m will cancel out. It will be equal to g minus n upon m. N upon m. Yes. What is this? This will be 10 minus, what is the value of n? That is 600. That is 600. Yes, exactly. It is given that the reading on the scale of the weighing machine is 600. Why? What is the reading? Reading will be that for every action there is equal and opposite reaction. How much is that weight? Will opposite by the normal reaction, that will be equal to 600 upon what is the mass of the body? It is given that mass of the body is 80 kg. It's 80. It will be equal to 800 minus 600 upon 80. It will be equal to, the answer is 200 upon 80. This will cancel out. It will be 2.5 meter per second square. And in what direction? It will be downwards. It will be downwards. Downwards. I hope it's clear to you. I hope it's clear to you. I hope it's clear to you. Okay. The answer is option number. It is option number. At around it's 2.3. The option that is matching, that will be 2.3 meter per second square. It will be downwards, not upwards. A and B, the value are same, but the direction is different. The direction is different. Is that clear to you? Okay. One more problem. We will do one more problem. Next problem. This is the next problem for you. Tell me the answer for this problem. Tell me. What's the answer? Okay, what's the answer? This is the last question for today's session. The rest of the questions we will take tomorrow. The rest of the questions we will take tomorrow. There are inclined plane problems. There will be some pulley problems, constraint problems. We'll do in tomorrow's session. This is the last problem in today's session. Tell me the answer for this question. Do this question in full energy. Tell me answer. Yes. Tell me the answer for this question. Tell me the answer for this question. Tell me the answer for this question. No one is giving the answer. No one is giving the answer. Tell me answer. No one is giving. Asif will be option A. Hafid option B. Hafid question mark. Rizwan option A. Option A. Okay, yes, option A is correct answer. Option A is correct answer. Yes, Rizwan. What will be the answer? How can you tell me the answer? Yes, the way is that you have to, what you have to do, how can you lower a 200 kg body? You have a 200 kg body, mass is 200 kg, and you have to lower this using a cord. Cord is nothing but it is a string. Roof, house using a cord with a braking strength. It means there will be tension in this direction. What do you have to do? Here it will be weight of the body, W equal to mg. These are two forces. And where will the body will go? Without breaking the rope, without raking the rope, what will happen? This rope will elongate here. This rope will elongate here. This is a cord. It's not mentioned. It is a massless, and sorry, if not mentioned it will be massless, but here it is inextensible, so that the body will go in downward direction. What will be the net force on a body? F net, that will be equal to mg minus t. What is F net? Ma minus mg equal to mg minus tension. Given that it will be equal to, what is the value of m? M is given that 200 into A, it's equal to 200 into, what is the value of G? Not mentioned. It will be G minus, what is the value of tension? Braking strength 160 kg weight. 160 kg weight means that it is 160. Braking strength means how much, what is the maximum force that you can apply? That is 160 kg weight, means that is W equal to mg. Mass is 160 and acceleration is G. What will be this? It will be equal to 40 G. This is 200. A 10 will cancel out. Acceleration will be equal to G into 4 upon 20. 4 1 are 4 5 are, it is G upon 5. It's G upon 5. And the option that is matching, one is 1.96, 9.8. If we take G equal to 10 upon 5, it is 2. And if we take G equal to 9.81 upon 2, the answer will come out to be 1.96 meter per second square, and it will be downwards. It will be downwards. It means option A is correct. Option A is correct. Hope you understand today's session. In tomorrow's session, we will take similar type of problems, mostly inclined plane problems. Mostly we will take pulley problems, constraint problems, and this session will be over. So what we are doing some of the numericals related weight of the body, some numericals related to tension of the body, some numericals related to the weighing machine, some numericals related to lift. These are the frequent problems that are asked in your examination. Okay, thank you.